Good morning, everyone. Welcome to the third installment of our HNES Showcase series, where we have our previously funded projects who present on some of the case studies of their funded projects, lessons learned, how they're getting on, and what improvements have been made. This one's focused on Greater London, and what we'll do, we'll give it a couple minutes while people trickle in, and then we'll get started. Great, I think we can get started. So as I said, thank you everyone for joining our HNES Showcase series, this time focused on projects in London. Before I go through the agenda, just thought I'd go through some housekeeping slides. So automatically, if you're not a speaker, your microphones and cameras are turned off automatically, just to improve video quality and bandwidth, and to prevent anyone accidentally having their microphones turned on during a presentation. If you do have any questions, we have the Q&A functionality. Please put your questions into that section, and we'll either get to them at the end of presentations or at the end of the webinar, or if there's anything that wasn't answered, we'll try and get back to you offline, and we will send out a feedback form as well. Now, at the end of that feedback form, there should be, once we send it out, there will be links to the recording of this webinar and the presentations. As you will see, the presentations automatically being recorded as well. So yeah, we will. If you do miss anything, then we will send those links around after the webinar once they're all uploaded. So got a really packed agenda today. So our program manager will be going through HNES funding today. So that's everything, sort of figures and how we're getting on so far, how much funding's been awarded, and the types of projects we're funding. And then we've got our lovely project speakers. So Jennifer McLean from Notting Hill Genesis will be going through the improvements enabled through HNES to the Glyn Street Estate project. And then we've got Zoe from CityGen E.ON, who will be going through the CityGen Heat Network project and the improvements that were made there as well. And then our application and grant funding lead, Katie Ansari, will be going through how you can benefit from HNES funding if you're thinking of applying to the scheme in a future round. And then if we've got time, we'll have a Q&A at the end. So without further ado, I will hand straight over to Louise, our program manager, to talk through HNES funding today.
Thank you very much, Michael. Thank you everyone for joining. So I just wanted to give you a bit of an idea of where we are with the scheme. So the scheme launched in February 2023, and we've now, as of yesterday, announced our funding round for round 10. So the next slide details the number of projects that we funded. So yeah, 449 projects have been funded so far. Over £81 million worth of capital and revenue funding has been awarded, and we have over 80,000 residents benefiting from the funding that's been issued. In terms of carbon emissions saved, so a nice stat that Michael likes to pull out is looking at one-way flights from London to New York. So yeah, over 124,000 flights worth of carbon has been saved as a result of the work that we're looking at. So all very positive on that side. We have a range of different sectors that have been funded, so predominantly housing associations, but also a number from local authorities in the private sector as well. We have also funded previously NHS trusts, universities, so yeah, a wide range of organisations as well. If we go to the next slide, so as I mentioned, our press release was issued yesterday for our round 10 projects. So there's a link at the bottom of the slides, and the slides will be shared afterwards. So you can have a look at the projects that were successful, the types of measures that they were looking to install. But just again, the high level figures. So we've got £15.6 million awarded in that funding round to 94 heat networks. With over 10,000 residents to benefit. So just a couple of pictures there. So we've got the University of Chichester at the top. On the right-hand side, we've got the Ridings, which is a Guinness Partnership Housing Association development. And at the bottom, we've got Walsall Housing Group, who also received funding. So like I say, 94 projects were funded. So there's a whole range of projects to look at on the press release. But obviously this session is looking at London and the Greater London area. So across those 10 rounds, if you go to the next slide, Michael, we have funded 179 projects in the Greater London area. 57 of those are capital projects and 122 are revenue projects, and over £33 million has been awarded in this region as well. So London does make up the lion's share of heat networks in England and Wales. So proportionally, the funding they receive is kind of proportionate to the number of heat networks in the region. And that was kind of all I wanted to say on this, what we've achieved so far for the 10 funding rounds that we've had of HNES. So I'll hand over to Jennifer so she can talk you through one of the funded projects.
Thank you very much, Louise, and thank you to Talon for asking me to speak this morning about Gwyn Street Estate. So my name is Jennifer McLean. I'm the Major Works Project for Notting Hill Genesis, and I've worked for the organisation for the last 4 years, specifically dealing with HNES retrofit projects. So next slide, please. So yes, Gwyn Street is obviously, it's a site within London, it's within the Lambeth Borough area, and it's a 69-unit dwelling. It's a project that we put through a optimization study and resulted in converting the communal heat network system entirely. We started delivering the project in July 2023. And it was commissioned approximately 8 months later in February 2024. We delivered this project through Fairheat as our principal designers and principal contractor, and they subcontracted the actual delivery of the works to Watkins. And also we have carried out since a post-works performance review, which was completed in 2024 to allow us to measure the benefits of the works that were successfully completed. Next slide, please. So this is an image of Gwyn Street, which is a very short walk away from Vauxhall Station, if any of you know that local area. Although it's called Gwyn Street Estate, it's actually 2 blocks named Dexter House and Muscovy House. As you may know, in social housing, we do like to have 2 names for most of our development sites. So yes, so Gwyn Street is what I'm going to be referring to it as in the rest of the meeting. It comprises of 37 rented units and 32 leasehold units, and it was built in 2010. Next slide, please. So in terms of the background of the site, it was approximately 12 years old when we started noticing some system underperformance issues. Primarily high energy use, very significant overheating, and poor resident experience. Obviously it was a 4-pipe system providing heating and hot water, like many of those communal heating systems built in that time. And in 2022, we made good use of HNES optimization stroke revenue funding stream to actually proceed with a optimization study that year. We appointed Fairheat, our heat consultants, to do the optimization study, and we received the full report in September of that year. Next slide, please. So obviously, when Fairheat carried out the study, they identified that there were key issues affecting efficiency and cost of the project. So there were significant heat losses due to the full pipework design. Obviously, because of that high heat loss, there were elevated gas and electricity consumption, and the plant operation and its controls were generally inefficient. The heating units within the dwellings were actually not performing well. There were units that were bypassing, and also it was identified that the insulation was not of a good standard. There were areas that were missing, and generally it wasn't compliant with current building regs in terms of thickness of insulation. So all of that increased our operational costs quite significantly, and obviously it also meant that we were having quite high carbon emissions from the site. Next slide, please. One of the most notable and concerning issues that we had at Glyn Street was the overheating in the block. It was very, very noticeable just how hot it was in the communal landings and communal corridors, to the extent that you walked into the building and you had to take your coat off, even in kind of the coldest winter days. So we were recording temperatures of 32 degrees in winter, and that got up to 40 degrees Celsius in summer. Residents were actually forced to open their windows because of just how hot it was. They were not able to, they were effectively not putting on their heating within their homes because they were relying on the heat loss throughout the building to actually warm their homes. And of course, residents were finding it very uncomfortable to come and go from their homes through the communal areas because of just how hot it was. And the reason we knew that the temperatures were so high is we actually fitted temperature sensors throughout the building on all levels and each side of the block, so that we could actually record the heat, and we could then measure what impact the actual heat improvement works would have on those temperatures going forward. Next slide, please. So other key issues that were identified were obviously risk of scalding from high temperatures. The domestic hot water temperatures were recorded as high. The cold water system was unstable, and there were frequent reactive maintenance call-outs. I think we had a maintenance rate of 1 in 6 HIUs requiring regular attendance, and obviously a lot of those HIUs were bypassing, as mentioned earlier. So overall, there was a risk of service failure and significant disruption to the heat supply for residents. Next slide, please. So we used our optimization study to support a capital application for HNES grant in round 1. The project was valued at almost £1 million, and we were successful in 2023 of gaining grant in the amount of £461,000. I won't go to the nearest pence. And of course, as with all HNES capital applications, we obviously need to match. We needed to match on that. So that obviously we were spending almost £500,000 of our own money to support the implementation of the project. Next slide, please. So the solution, the scope of work that was put together by Fairheat was to convert the 4-pipe system to a 2-pipe system. Luckily, the pipe work was actually in quite good condition. despite the heat loss. So we were actually able to retain the existing pipes rather than actually take them out and fit in new pipework. Obviously, we removed the central domestic hot water system, and we installed in each home a new HRU, new heat meters, and smart meters called, in this case, they were Guru hubs. We also obviously enhanced all the pipework installation to the current building regulation standards. So in most cases, we were looking to install insulation of around 50 centimeters. Sorry, 50 millimeters even. And obviously the focus in terms of driving efficiencies was to focus on reducing temperatures and improving the system controls at plant level. Next slide, please. So as some of you may know, the HNES scheme does not allow to replace boilers because boilers are a non-eligible item. In this case, we were able to make reuse of the existing boilers and the distribution pipework, as mentioned earlier. The plant room was reconfigured to include thermal storage, and we introduced weather compensation measures to reduce the flow temperatures across the network. Also, obviously, a key improvement was to install water quality equipment and remote monitoring devices. So we installed a side stream filter, a degasser, vacuum degasser, and we installed remote monitoring of the water system through a device called HEVASure. Next slide, please. Okay, so within the homes, as I mentioned earlier, we fitted Guru hubs to allow that improved visibility of how the heating units were functioning and how the network as a whole was running. So the plant room was also metered. Some of the existing metering was retained, and obviously we connected the new system to a remote BMS platform. That remote platform allows us to see at any one point in the day on a live basis how the plant room is operating, and it will give us obviously access to auto alerts, notifications should any aspect of that plant not be working as it should be. And the same for the water quality. Through the HEVASure unit, we're able to get notifications on what the water quality is looking like and whether it actually, any of the chemical indicators are indicating any problems with the water quality itself. Next slide, please. So in terms of gas consumption, we obviously have carried out that post-monitoring work since the project was completed successfully in 2024. And 1 year on from that, we identified that there had been a 45-degree reduction in gas cost, which exceeded the original business case, which was a target of reducing gas consumption by 39%. And we have seen sustained energy savings across the monitoring period, including electricity reduction. Next slide, please. So here is a very simple line graph just to demonstrate visually the reduction in gas consumption that we saw post completion of the works. So obviously in 2022 and 23, prior to the actual works being completed, we had quite high levels of gas consumption, up at 100 or around 180,000 kilowatts per winter period. So this data is looking at the gas consumption in December, January and February each year. And obviously from 2024 onwards, you can see a decline in the amount of gas consumption used by the plant system. And that has continued to decline through to the latest figures, which cover December to February 2026. So it's gone down to 118,000 kilowatts from that initial spike of 184 in 2023. Next slide, please. So this bar graph obviously just shows similar in terms of how much electricity the site is using across the winter months. And again, you can see quite clearly that in December, January, February 23, and the same period for 24, the electricity consumption was quite high. And obviously from 24 and 25 to 25 and 26, those winter periods, the electricity consumption has quite dramatically reduced. We have found that for most of our HNES projects in the post-monitoring period, we are generally seeing between 30 and 40% reduction in both gas and electricity consumption after the works have been completed. Next slide, please. So I mentioned earlier that we had fitted temperature sensors across the building in each of the landings, and this graph actually shows the decline in temperatures within each landing area. So obviously we can see that the corridor temperatures are actually down to around 21, 22 degrees Celsius from those initial very high temperatures of 32 degrees to actually up to 40 degrees in the summer period. So we can see quite a measurable decline in the heat loss and the heat temperatures there. Next slide. Of course, prior to the HNES works, we had very limited visibility of the network, and certainly we didn't have any visibility of how the individual HIUs were operating and their performance indicators. Now we have a really good level of insight into how the HIUs are functioning and the average return temperatures that are going through them. So this is an example of the data that we get from Guru, from the Guru Hub via the Pinpoint portal. So it gives us an indication through a traffic light system, essentially, of which sites, which HIUs are performing really well, and where you can see the green indicators, that's showing you that the HIUs are working well, and obviously the flow rates are also within acceptable parameters. And actually what we are able to do is regularly monitor this data, and where any of those indicators turn to amber or red, we can actually deploy a heat engineer to actually ascertain what is potentially going wrong with the HIU unit. So we can often send an engineer to a resident's home to check on the HIU prior to the resident experiencing any particular issues with their own heating and hot water supply. It means that we're able to do a lot of preventative maintenance rather than having to deal with reactive downtime on heating and hot water supply. Next slide, please. And this is an image, again, taken from Guru Pinpoint. We have Guru meters, obviously, connected to our risers at block level, and we can see that the flow temperatures and the return temperatures are looking very good. Obviously, the flow temperatures through the risers are 56 degrees Celsius, and we have quite a strong delta T. We have a 21 degree delta T. So that means obviously that the temperatures are coming back through the system much lower, and it shows us that the HIUs are doing their job well in terms of obviously giving the heat to the actual resident in terms of their heating and hot water services. So yes, we're really happy with those performance indicators on the flow and return temperatures, and it indicates that the system is still working very well, kind of 2-3 years post the works being carried out. Next slide, please. So again, some figures just to illustrate how effective the project has been. So we have our heat loss reduced to 167 watts per dwelling, which is approximately 70% reduction from the baseline. We have seen a significant improvement in overall system efficiency. We had no site outages in terms of loss of heating and hot water services at all in the last financial year. And we only had one the previous financial year, which was in August 2021. So obviously the HNES works have really enabled the system to become very robust, efficient, and basically to prevent those unplanned outages that really affect residents in their home. So we've actually also had no reactive maintenance repairs, so at HIU level in the last 2 financial years. Obviously they're brand new HIUs, so you wouldn't expect that to be the case anyway, but really pleased that those HIUs are working so well in those homes since they were installed by Watkins. Next slide, please. So, as mentioned earlier, we have got good flow temperatures across the system with weather compensation. The return temperatures around 35 degrees Celsius, and on average a delta T of around 25 degrees for each riser. So a much more stable system, improved controls, and essentially the performance meets the practical expectations of what we expected to deliver through the works. But the funding, the grant funding, the grant funding that we received. Next slide, please. So just a summary of the outcomes achieved. So corridor temperatures significantly reduced by approximately 10 degrees. We had 100% access rate to properties to install the new HIUs. So we had no access cases, which was great. Maintenance calls have been significantly reduced. Obviously, that's a great cost saving for us as an organisation, and obviously it means that the residents aren't being inconvenienced by having to make lots of repair requests. So we have a stable and efficient network, and 84% of the residents actually who responded to a resident survey said that they were happy or satisfied with the communal temperatures post the works being completed. And this approach has obviously provided a practical replicable model for doing other similar projects across NHG's portfolio. In fact, we have recently completed another full retrofit of a 4-to-2 pipework system at Baths Court, of which we actually won an energy award for last week. So really pleased with that as the best residential project of the year. And we are also doing another 4-to-2 pipe conversion works at another supported housing scheme called Ernest Harris House at the moment. So yeah, it just provides us with a really clear model of what can work and the benefits of applying for HNES funding, and also the benefits for customers who might have obviously been at detriment in terms of inefficient, old, non-performing heat networks. So that's me. Thank you very much for listening.
Great, thanks, Jennifer. Really interesting stuff. We might have time for a couple questions. I should caveat by the fact by saying that Jennifer isn't a technical lead at the project, so there are quite a few technical questions in the chat. But one question in the Q&A was whether you knew what the weather compensation technology used on the project was.
I don't know enough to answer that question. As you say, I'm not technical, so
no problem.
I don't know.
Yeah, no problem at all. I've just one other question here from in the chat from Marco. How did the lower individual heat consumption result in lower cost recovery?
Okay, so I think, sorry, I might have skipped through that in the presentation. So what I actually meant by that was because residents were not having to put on their heating because they were effectively, there was heat rising through the building from the corridors. Some residents actually said that they actually opened their front door to heat their home. They weren't actually using their own heating equipment, so effectively they weren't paying heating costs, but we were still paying those heating costs as an organisation, and obviously we weren't able to recover those heating costs because of the way that was set up effectively. So the system is much fairer now. Obviously we have lower heat loss, and where necessary residents are putting on their heating and they are paying for an efficient, effective service.
Amazing, thanks, Jennifer. And just one more quick question. There's quite a few coming in the chat, but we're going to have to move on in a second. But Ellie asks, how did you manage changing previous billing methods to charging customers based on smart meter usage?
So I would say we had, so there was always heat meters in the HIU, so they were already being billed by our external billing provider. So that didn't change. It just meant that obviously the accounts, the heat accounts needed to be updated with the new HIU meter serial numbers and the new readings. It just meant that residents could have much more visibility within their own home of how much energy they were using, and they could have much better control of their heating system.
Amazing, thank you. So I'm just looking at time. We're going to have to move on to Zoe at CityGen. Jennifer, would you like to continue answering questions in the Q&A over written comments? Then feel free to. If not, as I said, we will send out a feedback form. So if you've got any questions unanswered, then we can forward them on to the correct person once we send out the feedback form. So without further ado, I'll go straight to Zoe from CityGen. I think you're on mute, Zoe.
Sorry. Rookie error. Hi, my name's Zoe. I am one of the project engineers here at E.ON CityGen. I started my role here just over 3 years ago, and that was following our successful HNES grant application to manage the delivery of the project. My presentation today is mainly focused around the delivery of the project rather than the application process, and we just wanted to highlight some of the challenges that we had and how we overcame them working in central London. You could just click onto the first slide, please. So just a little bit about us, and apologies for not highlighting where we are on the map, but we are in the top left-hand corner. It's the busy looking one. We're a tri-generation energy centre in the Farringdon area in central London, and we supply heating, cooling and private wire to over 35 customers within the square mile. We deliver our energy via 11 kilometres of 300mm district heating pipe, predominantly running through car parks, various service tunnels under the city, and we've also got some of our pipe work which is buried in the ground. We supply several customers, different from heritage buildings such as the Guildhall, the Barbican and Smithfield Market. We've got some renovated buildings such as the old YMCA, which was recently refurbished to a high-end apartment block. And we've also got some highly efficient buildings recently built with customers such as TikTok and Snapchat. If you could click onto the next slide, please. Just to give you a brief journey of CityGen, we were originally commissioned in 1993, making it one of the oldest, if not the oldest, heat networks within the square mile. Originally commissioned with oil-fired gas engines as the main source of generation to a small number and predominantly City of London customers. 2014, we upgraded our systems and removed the oil-fired engines, and we replaced them with 2 high-efficiency gas CHP engines. And in 2016, new customers were starting to be introduced onto the network, with the interest growing in new connections for both heat and chill customers, and also introducing 2 customers to a private wire connection. From this original expansion, we've continued to attract new customers, with one of our recent connections being the New London Museum, which is just across the road from us here at Smithfield, and it's due to open later up this year. In 2019, we made a decision to lower our network temperatures in order to improve our efficiencies and improve supply to our customers. And as our original customer connections were designed to a temperature difference of 30 degrees across the heat exchangers, we had to upgrade our systems to compensate for the new and improved temperatures. In 2022, after several performance improvement initiatives supported by ourselves at E.ON, the HNES scheme offered us the perfect opportunity to take things further, with our main focus being improving the efficiency of the network through lowering utility usage. Next slide, please. The process for improvement began by reviewing the installed capacity versus the actual peak consumption, and we identified the sites that would benefit the most from the improvements. Looking at poor performing customers, we identified some of the root causes, including optimization of the size of the assets, poor water quality on the secondary side, leading to blockages of the heat exchangers, and the poor or lack of working control valves. Ahead of any major works, we work closely with our customers, offering our knowledge to improve their water quality and just to reduce the likelihood of them reblocking the new plates and also impeding the benefits of the new heat exchangers. Next slide, please. Taking all of that into consideration, we narrowed it down to the sites that are highlighted on the map in pink. They are consisting of 5 residential blocks. We have 2 original City of London connections on there and a student accommodation building, with the majority of the works being a heat exchanger replacement. Next slide, please. Challenges and how we overcame them. First, focusing on customer interruption and the nature of the buildings. The design process was quite detailed, and we did start work late in the year. We started in November 2023, not an ideal time to be interrupting customers' heating supply. So what we did was we made it one of our priorities to analyse what their patterns were and work around them. So we obviously identified that residential customers, they peak first thing in the morning and in the evenings, working around their work patterns. And so what we do in that scenario is we used to start working later on in the day and work to shorter days. So we'd have to program the works. So if we were like, and monitor it as we went throughout the day. Commercial customers, we either used to work after their morning peak, but if these customers were at a peak throughout the day, we used to work after hours. And there were a couple of jobs where we even worked overnight and over weekends in order to not interrupt their supply. This also helped us with having to reduce any interaction with people working in the buildings, and therefore we could work with a less risky scenario environment. Student accommodation, very unpredictable usage. Obviously, students, they either sleep all day, party all night, or it's all over the place. So what we did in this case is we opted for them to be at 0 occupancy. And then we were allocated a 4-week window in which we were able to carry the works with nobody in the building. The next item is data. Oh, no, sorry, go back. The next item is data. You don't realise how good data is until you don't have it. The lack of reliable data made our design process so difficult, but we've got some really good colleagues who've got a lot of experience using data, and using their knowledge we were able to assume a trend which was then incorporated into our design. And then the final one, and probably the worst one, working in central London, is access restrictions. Working in London itself comes with its challenges, but some of these historical buildings did not take plant replacement strategy into consideration. This caused us a number of challenges, which led us to one of the most rewarding installs that we carried out throughout the entire project. Next slide, please. The Guildhall. Stunning building, over 800 years old, which is home to the City of London Corporation, the mayoral home for the City of London, and hosting state dinners for kings and queens all over the world. And more excitingly, it's one of our original connections to the CityGen network. The original plant was lowered into the basement during one of the renovations over 20 years ago, and then sealed over with 0 consideration for us, any innovators, to come in years later. Next slide, please. The scope was to replace the old plate heat exchanger. This was last upgraded in 2008, and we were upgrading it with a twin plate heat exchanger with upgraded controls and replacing an old PLC controller which was no longer supported. Thankfully, there was a little bit of floor space in the plant room, which is a rare luxury for buildings in the city, which we were able to use to house our new heat exchanger. Next slide, please. This slide shows the new pipework installed at high level, which was we had to install this pipework from our existing network, span it across the plant room, and obviously, as you can see, it's supported on goalposts at high level. This is to we was to supply the heat exchanger in the new location. Next slide, please. As I mentioned previously, access restrictions. The plant room is located 2 stories below row level, with the final descent into the plant room being either the photo that you got on the left-hand side is a narrow staircase, very tight corners, and I think it's measured about 800 mil wide, or we had an even narrower 20 meters vertical access hooked ladder, which was 700 mil wide. But this gave us direct access into the plant room. Both had risks and safety concerns associated, which we took into consideration, and we had to, and obviously we considered the lower risk option. If you could just click on the next slide, please. The vertical ladder, if you could just click for the video, please. So after evaluating the risks from the manual handling to interacting with day-to-day personnel, we opted to lower the equipment directly into the plant room, which you can see in the video. We had to design the system so it fits through the hoops themselves, and we installed an electric hoist at the top of it, as you can see, to lower all the equipment. The actual speed was 2 minutes. I actually got my 20-year-old daughter to reduce that to the 5 seconds that you can see. I can assure you it wasn't that fast. But the heaviest item was 450 kilograms. That was the end plate that you can see here in the video. But over the weekend, we actually lowered a grand total of 5 ton of equipment down into the plant room using this method. Next slide, please. Just a few details of how we manage it. As you can see, the heat exchangers, they're assembled in the plant room, but actually the skid was assembled off-site. So our contractors, they measured out an area in their warehouse that equated to the space that we had in the guild hall. And they assembled it to match it so that when we came to the day of installing it, there'd be no upsets or hiccups. The total of there's around 180 meters of pipework, which is all prefabricated off-site. We had to keep it to a maximum of 2 meter lengths. This was to make them more manageable and also for them to just fit through the door. Each section of pipe was flanged at the ends, so they could be bolted together to reduce the need for hot works in the plant room. 4 end plates, each weighing 450 kilograms, and all the valves went down the ladder individually as per the previous video, and then the heat exchanger had to be reassembled in the plant room just like a huge Meccano set. The new control panel was installed, and we had to upgrade our control strategy, and we set it up to operate in a duty standby or a duty operation depending on the heat demand, and it also allows us to monitor our systems more remotely. And just to give you an idea of the additional controls that we did have added onto the new skid, I've got the following slide shows 2 P&IDs for the before and after. Just click onto the next slide, please. So apologies for not being legible, but I just wanted to demonstrate is the detail that we actually went into. So the top one is the old plate heat exchanger that we had. As you can see, very limited controls, and they're all on the primary side. The bottom picture shows the new plate heat exchanger, and as you can see, the more controls that we have on the primary and the secondary side. So this then allows us to control our return temperatures more efficiently. And the next slide, please, was the end results. So photos of heat exchangers, just about as exciting as they get, to be honest. They're even less exciting when they're all insulated. Shiny lag pipe is just as exciting in my opinion. However, joking aside, this for us was a successful result. It was a long and challenging project. It attracted a lot of attention internally. We've had articles published about it, but for us personally as a team, it's quite rewarding knowing that we managed to deliver what was deemed as impossible initially, and then we're now supplying a new improved heat supply to one of the oldest and, in my opinion, the most beautiful buildings in central London, despite the restrictions that we had. And that's it from me. Thank you very much.
Amazing. Thank you very much, Zoe. I'm just looking in the chat and Q&A. There's quite a few questions, but they seem to mostly be directed at Jennifer's presentation. So what I'll do is I'll move on to Katie's section now, and then if there's any other questions for Zoe or Jennifer, please everyone pop them in the Q&A, and hopefully we'll have some time at the end to take some further questions. So Katie, take it away.
Thanks, Michael. Great. So I'm just going to have a quick run through of the benefits from HNES funding. So there are 2 types of funding available, which is revenue funding, which covers the costs of the optimization studies for a third party to carry out, and the costs there usually range from £15,000 to £24,000, and that was what the full funding would be for. If you do have higher, if you do think your studies will be higher, we will need justification for that, and it may be partial funding instead. Again, it's subject to availability, but there is future rounds open, so we do believe you can still obviously apply for revenue funding. And then on the capital side, it's partial funding, so that's up to 50% but not including it, and that is for the delivery of all the improvement measures and the installation for that as well. As you can see there, we've got 105 million of funding approved between the financial years 23-24 to 29-30. Please note as well that the grant funding must be spent in the allocated financial year. It is important to keep the to avoid risk of losing any funding, and the match funding does not need to be spent at the same time as the grant. So if you have grant funding over, say, 26-27 and 27-28, you can use all of your grant funding during those allocated years and then the match funding after that. However, if you do want to split the match funding, you can obviously spend some match funding in those years that you've got grant funding as well. Just be aware that you will need to claim all the grant fund first to avoid it being lost, because it can't be. It should be spent in the correct financial year. And next slide. So, in terms of who can apply, we've got as you can see at the top there. So from round 12, any capital applicants must support customers in need. It is really important that you do so, or you need to have a good demonstration of strategic rationale for the funding. So any links to the GHNF, which is the Green Heat Network Fund, or heat network zones. But in terms of who actually can apply, then it's any operators of existing district or communal heat networks, heat networks situated in England or Wales, and the sectors involve the public sector, private sector, or third sector organisations, as well as companies that are legal entities with the authority to sign off on investment decisions. So things like management companies who have the authority to sign off, and companies such as that. But we would need evidence of that as well. Next slide, please. And just to go over then the important dates for the next funding rounds. So round 12 is open at the moment. Well, the last application, the date where you could request an application form is closed, but it's currently, we're getting submissions from those who requested them for round 12. That will be closing tomorrow. But then round 13 is expected to open on the 17th of August, and the last day to request an application form will be 2 weeks before the closing date, which we expect to be October 2026, around the 9th. And then on round 14 is expected to open December this year. Again, 2 weeks before the closing date is the last day to request an application form, and it's expected to close in February 2027. Again, these dates can change subject to availability, and we do have a link to our guidance for applicants at the bottom there. Next slide, please. Where to find help and support? Please email us at hnes@talon.com. You can read our guidance for applicants, and you can sign up to our mailing list, which will give you any updates on the latest information, round opening and closing times and things like that about the scheme. You can also read HNES's optimization guide and watch some guidance videos that we have links to there as well. And then the team is below, so it's myself, Louise, Alison, Roisin and Abby. Does anyone have any questions, or moving on to the Q&A for the case studies?
Great, thanks, Katie. I'm not sure if there's so there's a few questions coming in through the chat. What I'm going to do now is I'm going to bring Jennifer back on, if you're still there, Jennifer.
Yeah, I'm still here. Michael.
Amazing. Yeah, so just a few more questions for you. I know you've been busy typing away in the chat. David, during your presentation, asked, was quite impressed with the 100% access. Can you describe your booking system and process you had in place to gain access, and what are you replicating elsewhere to gain access?
Yeah, so essentially, I would say the key to 100% access rate is persistence and having an actual project team on site. So we had a full-time resident liaison officer for the project who was based in a cabin basically on the land outside the block. So he was literally building those relationships with residents as they came and went from the building, and doing repeated door knocks. And I think it's just really important that you build that engagement with residents, and that they trust you, they can see the work that you're doing, and they know it's going to make a difference. So alongside obviously the efforts of the RLO, it was about doing some good comms to explain the benefits to them of having the works done.
Amazing, sounds good. And then just sort of keeping on that theme of sort of resident engagement, Anupam asked sort of resident satisfaction. I think there was a figure that said 84% in there, and I guess I was just wondering, would that necessarily, are there any learnings to take from that, and how to sort of increase that satisfaction?
Yeah, I mean, obviously with resident surveys, you can never tell what's going to come back. I mean, I guess we would have expected 100% residents to say they were much happier with the communal temperatures, but of course, some people like a lot of heat. I don't think we could have really done anything else to actually change that particular stat.
Great. And then just looking in the chat now. So I know you mentioned sort of heat not being charged, yeah, sort of residents not being charged for heat to the communal areas. And Marco asked if the sort of rationale around that.
Right. So that was Marco's chat discussion earlier. So I think I covered that with a verbal response, but I don't know.
Did you? We may have covered that.
I think so, but if Marco's not happy with my answer, I'm more than happy to go over that again.
Sure, yeah, and as I said, we will send out a feedback form, so and we'll have an option for people to submit their questions as well. So if there are any others that prop up afterwards, then we can obviously forward details to the correct location. And then another one from David. I think this is probably more for our team. So Louise/Katie, have you seen any sort of delays in projects since building safety regulations have changed, and whether it's sort of the interaction between the scheme and certain policy mechanisms?
Yeah, I was just typing a response, but I can do it in chat as well. It's fine. We obviously, for anyone applying now, we would expect them to factor these kind of requirements into their project plans alongside any other legal obligations. So, for example, if you have to do a Section 20 process for leaseholders, for example. We have had projects that have experienced delays, not just because of building safety regulations, but obviously these are quite extensive projects, so projects do suffer delays. We do have a sort of change request process that applicants can go through, but there's no guarantee necessarily that the funding will be available. So it depends on the reasons why the delays have happened. It would potentially go back to DESNZ for review and approval. So but we do recognise that there are sometimes things that happen outside of people's control. So there is a degree of flexibility there, depending on the reasons why the delays have occurred.
Amazing. That's great. I'm just looking to see if there's questions coming in thick and fast. I'm just checking to see if there's any we haven't answered. But I think we've mostly. I was just typing in there's another question that's just come in to the chat. So this is a question for Zoe. Zoe, are you still on the call?
I am, yes.
Perfect. Yeah, so what questions just come in for you? I didn't want you to feel left out because there's been plenty of questions for Jennifer. But just one in the chat. This is talking about sort of like the finances in terms of who paid for the works, whether that's Citigen or the customer. So I guess this is sort of looking at, passing on benefits / costs to residents, etc. So, and if you wanted to cover that one.
So with regards to who paid for the works, that was us, Citigen. Obviously, we had the HNES funding to support as well. Benefits are mostly Citigen. Yes, you're okay. There has been some improvements to the Guildhall. I don't really monitor the data, to be honest. I'm more on the delivery side, like I said, but I do speak to the energy centre manager quite a lot. And obviously, it's more also the return temperatures that we get that we're able to control better now. Do we own and maintain the heat exchanger? Yes, we do. We have over, I think it's about 32 heat exchangers across the network for both heating and cooling. We have heat supply contracts. With regards to the maximum return temperature, that's more of a question for our contracts customers, but I do believe there's a maximum temperature that we have stipulated in our contract. Can't really answer the financial incentive, I'm afraid, but the improvements are typically on the customer systems. Yeah, I mean, we bill our customers for the heat that they use. We don't, and obviously they have a standing charge, but that's as much as I go into the financial side of it, unfortunately.
Amazing. Thank you very much. Really helpful, Zoe. I think we'll probably leave it there. As I said, if there are any questions that are unanswered, we'll review it afterwards and pass on the questions to different to the different speakers as required. And as I said, we will be sending out a feedback form to have another opportunity for any attendees to ask any questions of our speakers, and we will of course forward you the responses once we get them through. So again, big thanks to our speakers, Jennifer and Zoe, for taking the time today to present on their funded projects, and to obviously my colleagues on the HNES team, Louise and Katie, for giving a bit of an overview of the scheme itself. Thank you for everyone for attending, and again, please do follow our socials as well for more information of when we're holding our next webinars and different areas of the country, and we will, I'm sure, be in touch soon. Thanks all.
Thank you.
Thank you. Bye-bye.
Thank you very much.